Dear esteemed chair, dear audiences, my name is Ulmann, and my PhD thesis title is about the new insights on the prognosis of pancreatic ductal adenocarcinomas. I'm a surgical resident and a second-year PhD student here at Semmelweis University Department of Surgery, Transplantation, and Gastroenterology. My supervisor is Akor Such, my SMS is Mahmoud Obeidat, and my vision is to be able to combine the research and knowledge in the surgical treatment of pancreatic cancer. And in order to achieve this, my mission is to research how the different pancreatic mutations lead to a different prognosis. So I have two specific goals with two specific projects, and I will outline each of them at their own stand. So my first project is a systematic review and meta-analysis, which is investigating the prognostic relevance of micro-RNA analysis of pancreatic ductal adenocarcinomas. So as a background, in order to introduce the topic, PDAC is one of the worst prognostic cancer types in the world, with a 5-year survival rate of around 7%. So what do we tell the patients? Is this only a homologous disease, or does it have any heterogeneity? Well, one possible solution for that could be micro-RNA analysis. Micro-RNAs are a little type of nucleotides which affect the development of pancreatic cancer proteins, acting either of these four groups: as oncogenic microRNAs, tumor suppressor microRNAs, chemotherapeutic resistance-related microRNAs, metastasis-related, and multifunction microRNAs. Thus, my aim with this project is in order to investigate the prognostic relevance of these microRNAs in PDAC. For this project, I have used the PFO framework with population or patients diagnosed with PDAC. Prognostic factor would be the high and the low microRNA expression, and the outcome will be measured in overall and prognostic-free survival. And my clinical implication would be detecting the different survival rates in patients with PDAC. We have done our systematic search in 3 different databases, and you can see our search key there. First, we initially started out with more than 11,500 articles and turned out to be 148 for the full text selection. I will start out with my results first. So first of all, I will outline the individual patient data. On this table, you can see the overall survival by the microRNA categories. You can see that the highest median survival time was in the oncogenic microRNAs, having a low expression with a median survival time of 24.71 months, and where it was a high expression, it was 16.8 months. You can see the survival graphs with the same subgroups of these microRNAs, with the blue line representing the survival of the higher rates of microRNAs and the red line representing the lower rates of microRNAs. After that, I will turn to the univariate overall survival analysis. First of all, about oncogenic microRNAs. You can see that the overall hazard ratio was 1.71, which was actually statistically and clinically significant because most of the studies were above the line of no effect. Second, turning to microRNA 21, which was our most significant results in this type, with a hazard ratio, an overall hazard ratio of 2.37. And you can see that this was also clinically and statistically significant. It could potentially be used as a biomarker. And third, going on to the chemo resistance related microRNAs, this analysis was actually lacking a little bit because some of the studies have not outlined the type of chemotherapeutic agent used either as neoadjuvant or adjuvant therapy. However, we could still see statistical significance with an overall hazard ratio of 2.56. Thus, you can see our overall outlines in here, overall results, and a star next to them represents the statistical significance. In the univariate survival analysis, this was presented the oncogenic microRNAs, chemoresistance, and the overall microRNAs. During the multivariate analysis, it was presented the oncogenic and chemoresistant ones, and during the progression-free survival analysis, it was presented the oncogenic, metastasis-related, and chemoresistant resistance-related microRNAs. Thus, the strength of our study is that we could see statistical and clinical significance in both the overall and progression-free survival groups, and we have involved a great amount of studies, and we have provided information about the possible chemo resistance. However, there was actually a heterogeneous population with many subgroups. We don't know the exact pathophysiology pathways behind these microRNAs, and we have not just involved RCTs, but rather 30% of these studies were actually retrospective cohort trials, thus more RCTs are needed. But we could still conclude that microRNAs, especially microRNA 21, do hold a significant prognostic value for patients suffering from PDAC, and we have our implication for practice with predicting disease prognosis, chemosensitivity, and improving the personalized disease management strategies. Our implications for further research will be standardized serum level tests for the low and the high expressions, researching the sensitivity to individuals to individual chemotherapeutic agents, and optimizing disease management protocols. Our current status with this article is that we have first submitted to Lancet, who has transferred it to Lancet Oncology, and it's under review since 3 weeks now. My second project is about comparing the prognosis of patients treated with borderline resectable pancreatic cancer receiving neoadjuvant therapy or upfront surgery. This will also be a systematic review and meta-analysis. In order to introduce the topic, there are 3 types of PDACs, 3 types of groups: resectable, borderline resectable, and in the advanced stage. However, most of them, I mean, all of them, it's true for all of them that surgery is the only chance, but only around 15 to 20% of them are actually resectable. Without resection, the 5-year survival rate is around 7%, but if it's resected, it goes up until 15 to 30%. Thus, the aim of this study is in order to compare the effect of neoadjuvant therapy with upfront surgery in borderline resectable PDACs. And one note on the background of borderline resectability is that therapy is actually today in the clinical practice is defined by 3 different categories: the biological behavior, the radiology, as in surgical resectability, and the patient performance status. Thus, for individual disease management strategies, we need to consider short and long-term survival rates, compare the cost and benefit analysis of neoadjuvant therapy and upfront surgery, and determine which actual patient population should be considered for which specific type of neoadjuvant or actual therapy. So we have used the PICO framework in this case with population of patients with borderline resectable PDACs. The intervention will be the different types of neoadjuvant therapy or control group where primary surgical resection, and the outcome will be measured in overall and progression-free survival, percent of operability, R0 resection rate, reoperation rate, and post-operative complication rate. And we are hypothesizing that neoadjuvant therapy is safer and more effective in the treatment of borderline resectable PDACs than the actual primary surgical resection. You can see our selection flowchart here. We have started out with 1,500 articles and ended up with 5 of them, and these are all RCTs. And you can see our progress here. We have extracted the data, and we are starting the ROB right now. So in summary, I have 2 ongoing projects, which first of them I have submitted already, and the second one's planned submission will be in August 2025. My additional activities are teaching at my home department for the Hungarian, English, and German surgical students, and I have presented 2 conference presentations at FISES 2 times at the Hungarian Association of Young Surgeons, and I was recently in June at the HAPBH conference in Dublin. I have done a poster presentation there. I'd like to end my presentation with a quote from John D. Rockefeller: "If you want to succeed, you should strike out the new paths rather than travel the worn paths of the accepted success." Thank you very much.
Thank you very much. Is there any question? Okay.
Congratulations on your presentation. I would like you to ask regarding the first project that what samples were used. So which samples were this mRNA analyzed?
Thank you very much for the question. Most of them were actually tissue and plasma samples. There were a couple of studies that were limited to tissue samples, but most of them, around 90%, included the plasma samples and tissue samples too.
Thank you.
Thank you.
Thank you very, very much for your presentation. My question is about these micro-RNAs, because they're all the rage about them nowadays. Do I understand you correctly that they can be used alongside the traditional screening tools, not instead of them?
Thank you for your questions. There are actually ongoing studies, and there were a couple of them already published, which actually outline the use of microRNA 21 alongside the tumor markers of CA or CA19,9, and they have seen that the sensitivity and specificity to actually increase when using them both at the same time.
Thank you very much.
Thank you.
Congrats on your presentation. I have some questions for the second project. What was the chemotherapy regimen for the neoadjuvant therapy, and how many cycles of chemo did these patients receive before the surgery?
Thank you very much. The current actual strategy for borderline resectable PDACs is either Gemzar, or so gemcitabine, or modified FOLFIRINOX. So these patients receive that, and the actual number of cycles were actually depending on the patient. So it's either around 2 to, let's say, 6 of them.
Could you do the subgroup analysis based on the chemotherapy regimen? Because I believe the results would be very much different.
Yes, we could do it, but we haven't. Well, the results are done, but we haven't done the statistic yet. So yeah, we'll definitely do a subgroup analysis.
Only one question, and I will finish because it's very important for me as I have pancreatic cancer patients. You said that the number of cycles in the neoadjuvant therapy varied. What about the adjuvant therapy? Did they decrease the cycles from the cycles that they would have received in the adjuvant treatment, or the cycles were added to the numbers of the cycles in the adjuvant treatment?
Well, this data was focusing actually on the neoadjuvant therapy. So they did outline the type of adjuvant therapeutical agent that they have used in the borderline resectable group, or so after the surgery, but they did not definitely outline the number of cycles in there. So they were rather concentrating on the neoadjuvant therapy, and we're actually doing the subgroup analysis based on that. So not adjuvant, but rather neoadjuvant therapy.
Thank you.
Congratulations.
Sorry.
Okay. So regarding your first project, is there any baseline characteristic differences between the two groups to the high level of MRI, or I mean in the context of resectability or irresectable, or do you have any data about that? So it is the pool data, so it is metastatic patients and locally advanced and resectable patients. So what is the population you based on this MRI, MRI groups?
Thank you very much for the question. It was actually a heterogeneous population. So the first project actually included resectable and borderline resectable groups too. So as you could see in the chemosensitivity subgroup, many of them outlined the actual neoadjuvant or adjuvant therapy that they have used, but they were rather not concentrating on that. They only outlined their names of the actual agent. So we could only predict that, and you could also see our heterogeneity numbers, that they were actually, some of them were actually significant, because a lot of types of PDACs were included in this data.
Okay, thank you.
Yeah, that was a very good presentation, Lőrinc.
Thank you.
Peter Hedge is fascinated by Nobel laureates. Who got the Nobel Prize for microRNAs?
I'm not sure about that.
It was given out last year to Victor Ambros and Gary Rarkin. You've shown us in your meta-analysis like the usual suspects that are on a panel, and that many studies have used these panels of around 50 microRNAs. There exist about 12,000 microRNAs. Is there any conclusion from your study what are likely candidates one could test in a prospective study other than 21 and the others that everyone has looked into, which you have wonderfully analyzed?
Well, our actual targets are also 21 and 200 A, B, and C, actually. Specifically with microRNA 200C, we do see a significant value. And one of my colleagues here at the surgical department has outlined the use of microRNA 200C in IPMNs. So those are the two subjects that we're actually targeting, and we were actually just about a month ago discussing a prospective randomized trial about this, including the microRNAs and the oncological, like neoadjuvant or adjuvant therapy, with the use of these alongside the tumor markers. So I would have those two as my targets.
Yes. IPMNs have a very different genetic profile. Maybe you find some microRNAs that are more tailored to that profile that you may find in stuff. So I would predict that they may have very different microRNA profile than actual pancreatic cancer, which does not necessarily have to arise from IPNN. For the, I don't know whether I got this correctly. Is this a meta-analysis you plan for borderline resectable, or is that an actual study you plan for borderline resectable?
It's a meta-analysis.
It's a meta-analysis.
Yes, exactly.
Will you include, or are there enough studies on radiation therapy for borderline resectable? Because radiotherapists think they can solve this problem.
Yeah, I was actually just at the conference in Dublin, and they have outlined this in detail. So they did not see any significant prognostic factor in the radiation therapy. So they would actually, as neoadjuvant therapy, they would actually just use the modified FOLFIRINOX if possible. But in this case, there was actually one of the RCTs that has had 3 arms, and one of them did outline the use of radiation therapy. But there was no actual prognostic relevance to that.
Thank you very much.
Congratulations. I have numerous questions concerning the mRNA study, which is quite interesting, and hope it makes it to Lancet Oncology.
Thank you.
What do you mean by high and low mRNA expression? What was the cutoff for high and low? And how can you compare tissue and plasma? Are they sort of changing in similar directions, or is it possible for the tissue to decrease and increase in the plasma? Like, for example, in case of tissue destruction, I could sort of imagine that they could maybe even change in a different way. And maybe I would just ask the costs of the mRNA profiling.
First of all, to start out with your questions, microRNA profiling in today's date is actually, the costs are really high, which is actually the primary reason why they don't necessarily routinely use it in the clinical practice. And to further go on to answering your questions, that was our initial problem with this study, that the cutoff values are not exactly defined. What they did in there is that they have done the microRNA profiling, and they actually did a cutoff value of around 50%. So under 50% of the concentration of microRNAs, in this case of PDAC, they said that that's going to be a low expression, and above 50%, they said it was a high expression, which is why I have outlined in one of the limitations of our study that we actually do need these specific cutoff values. And to further go on to answering your question, yes, there is a problem with tissue destruction, but what we could see and what studies have actually investigated is that even though the concentration of tissue and plasma samples are not exactly the same, but they do show a trend in the oncological behavior of these.
There are no questions. Can I just ask one more?
Yeah.
And you sort of categorize the mRNAs in ways. What about overlaps? How do you treat overlaps? So are microRNAs only categorized into one category, or sort of numerous categories as well?
Let me just go back. So what we could see in here. I have outlined the term of dual role microRNAs. We did have some of the overlaps, and we actually have multiple role microRNAs, but we have not outlined them that much into detail because the forest plot in there would be limiting. And since there would be so much heterogeneity, we did not take that data into account, but we did take into account that the univariate analysis, the dual role type of microRNAs.
Okay, you told that the cost is high for this analysis. What do you think in the future? Is it possible to design rapid tests against these kind of specific mRNAs?
Thank you for your question. I do think that in the future it's going to be possible to design cheaper tests, but what I would actually rather focus on is a type of molecule which attaches to that specific type of microRNA that we are trying to investigate. So rather than having a whole microRNA profile which would increase the cost significantly, I would actually, what we have outlined with your colleague there, I would actually concentrate on one or two type of specific microRNAs in the future to use as a biomarkers, such as alongside CEA or CA19-9, which would actually decrease the cost that way.
Okay, thank you very much.
Thank you.
Other questions? Okay.
Hi. I was just wondering, how did you find the cutoff of clinical relevance for your results? Because you mentioned that they're significant for statistically, but you also mentioned that they're clinically relevant. Was there a cutoff, or how do you measure that?
Well, we based our clinical significance on the individual patient data. So we actually investigated with the web plot digitizer, we could actually conclude an XY axis, and through which we could actually see the cutoff values at the time intervals that the actual patient has died. So yeah, that's how we did it.
Thank you.
If not, oh, yes.
It's a sort of theoretical question that do you think that maybe we can or you can perform a scoring system or ratios based on your findings to predict the prognosis or survival? So combine the oncogenic and tumor suppressor microRNA profiles, ratios could be calculated.
Thank you very much for your questions. I do think that ratios would be possible to calculate. However, the reason why I would actually concentrate on individual microRNAs is the one reason that your colleague has outlined, the overlaps. So since we have overlaps in the microRNAs, I would actually rather concentrate on having only individual microRNAs alongside the today's used tumor biomarkers. So I would actually do the ratios basing on that and not the actual microRNA profiles, because it could be huge and vast amount of information.
Thank you
very much.